Good morning students, welcome to the day 6 session. Today we are discussing about free body diagrams. In the last session we have discussed about the effects of force. Effects of force increases with area of contact. As the area of contact is more, your effect of force will decrease. We have taken several examples to explain them, like pen, sharp knife, the blunt side of the knife and the sharp side of the knife. And also you can take many examples. You can take lime powder and you have to place two bricks, one in vertical position and the other one in horizontal position. What do you observe? After keeping the two bricks, one horizontally and one vertically, remove the bricks. Try to observe how deep they sink in the lime powder. It's so obvious that the vertically placed brick will sink more because the weight of the brick will be more, as the area of contact is less, more pressure will be there or more force will be applied by the brick. So like this we can explain many things about the effects of force. Today in this session we are going to discuss about free body diagrams. Free body diagrams are those in which we will show all the forces acting on an object at particular instant. Let me take an example of a moving car. If I take a moving car, the weight of the moving car will be acting downwards, and you can see the car will be on the road. The surface of the road will be having some friction. It will be showing some force of friction, and the force of friction is always in the opposite direction of the motion of the car. See, you can observe this force. The car is moving in this direction. That means the car is applying some force in this direction. It's so obvious that frictional force will be acting in the direction in such a way that it opposes the motion of the car, that is the opposite side. And coming to the next, the two tires of the, see, you can observe here, the tires of the car will be acting opposite in the upward direction, perpendicularly or normally to the surface of the road. So I am showing what all are the forces acting on the body with the help of an arrow line. See, now if I take a car which is moving with non-uniform motion, which is a non-uniform motion on the surface of the road, I am going to show the forces acting on the car here. What all are the forces acting on the car? If I show in a diagram, I call it as free body diagram, and I denote it as simply as FBD. Now, before going to draw the free body diagrams, why we have to draw free body diagrams? What is the purpose of drawing free body diagrams? Free body diagrams helps us to calculate the net force acting on a body. How to calculate net force acting on the moving car in this example? First of all, we have to take two coordinate axes, as you all know, this x-axis and y-axis. On this right side, you have to take these two axes as positive and the other two as negative. Now, what all of the forces will be in this direction, you have to take as positive, and what all the forces acting in these two directions, you have to take them as negative. Now, calculate net force acting along x direction, x-axis, and along y-axis. Now, here let me take along x-axis. In x-axis, what are the forces acting horizontally? One is the applied force acting in this direction, and the frictional force acting in the opposite direction. Now you tell me the direction which is in this direction is to be taken with positive sign. You need to follow the sign conventions for free body diagrams. Now what is the net force along x-axis? If you say this frictional force will be having positive sign, and as the applied force is moving in this direction, it will be taken as negative sign. Now total force or the net force along x-axis will be F minus F. In the same way, if I have to calculate the net force acting along y direction or y-axis, that means vertically, you see what are the forces acting in vertical direction. If you observe N1 and normal forces of tires and this weight of the car will be acting in the vertical direction. Now the total net force acting along y-axis are, see, in upward direction you will be taking them as positive. Now what are the forces acting in upward direction? N1 and N2. So take them as positive. So I have taken here F net y is equal to N1 plus N2. Whereas your weight of the car is acting downward. Downward you need to be taken as negative sign according to the sign conventions. So the total net force acting along the y direction or y-axis is N1 plus N2 minus W. This is how you will calculate net force along x-axis and y-axis. Let me take the example of duster. Now I have an object which is placed on the table. Now usually a body which has mass, or it is always attracted by Earth's gravitational pull and it should fall down, but it doesn't happen. Here in this case, as already discussed, it is kept on the table. It means that it is supported by your bench. Now its direction, see, if I take this object, its weight is acting downwards. Its weight is acting downward. When its weight is acting downwards, if a force is acting in downward direction, the duster should fall down, but it is not happening because it is balanced by the normal force which is acting in upward direction. What does it mean? Though its weight is acting downwards, it is being supported by the normal force which is exerted by your table. That means your table will be exerting an upward force balancing the weight. So because of the normal force acting in upward direction, your duster will not fall down. So what is the net force acting here? Its weight in downward direction, its normal force in upward direction. So normal force minus its weight. So here, as the body is not moving, we can say that its weight and normal force are same and they get balanced, and that's the reason why the body is in rest position. Let us move into several examples here. I have an example here. Let us take a first problem. Here, children, one more thing to be discussed is free body diagrams. No need to draw the shape and size, color of the object in your books. Free body diagrams are just, it's a diagram where the forces should be shown but not the exact shape and color or size of the car. So for example, if I have a car, if I have to draw a diagram, free body diagram of a moving car, I can just trace a box like this. No need to draw the car, or color and the shape of the car is not to be mentioned. I can just draw a square. Now if this is my car, I have to show what are the forces acting. For example, my upright force is acting in this direction, frictional force is acting in this direction, normal forces are acting like this, and its weight is acting downwards. Here in this free body diagrams, I need to show only the forces acting in horizontal direction and in vertical direction, but not the shape, size and color of the object is not mandatory or not necessary, first of all. Now let me take the example of first problem. See, I have an object. Now two forces are acting in this direction, 8 newtons, 10 newtons, and now 12 newtons force is acting in this direction. From the sign conventions, we already have discussed that along x-axis, along y-axis, if I take upward direction and right direction, I will take positive and the other two are negative. Now you tell me what all forces, what is the net force in along x-axis now? Net force will be F net is equal to, see, 8 newtons is in this direction along the x-axis. So my sign conventions for 8 newtons and 10 newtons will be positive as it is along the x direction. And if I take 12 newtons is acting in this direction, where I can take this 12 newtons as minus because of the sign conventions. Now you tell me F net will be 8 plus 10 minus 12. 8 plus 10 is 18. 18 minus 12 is what? 6. So, though many forces are acting on this body, 8 newtons force from this side, 10 newtons force from this side. So, total force acting from this side is 10 plus 8, 18, and it is opposed by a force of 12 newtons. So, they get they get opposed, and total overall only of 6 newtons force will be acted on the body. That means a body will move only with 6 newtons of force, though many forces are acting. This kind of problems can be expected in the exam. Coming to the next problem, let's see another problem. See here, I have an object. This is free body diagram, children. Now I have 8 newtons of force acting and 6 newtons. What is the total net force? Net force acting on the object is, see, 8 newtons, 6 newtons both are acting in this direction and nothing is opposing it. So I can just sum it. 8 plus 6, 14 newtons. So total force of 14 newtons is acting on this object. Let's take another example. If I take a body, let me take 8 newtons of forces acting along the x-axis and same force is acting in opposite direction. Then what is the net force acting on the object? F net will be 8 newtons will be acquiring positive sign according to the sign conventions. So 8 and 8 newtons will be acting in opposite direction. So 8 minus 8, I will take minus sign for this 8 newton because this is opposing the other force. Now 8 minus 8 becomes 0. Now what does this mean? If F net is 0, though two forces are acting, as both are balanced, I can say F net is 0. It means now no force is acting on the object. No force is acting on the object. It means that object is in rest position. So this is how we will discuss about. We'll get problems like this in exams. And let me recapitulate for this session. Free body diagrams are those diagrams for which we show what are the forces acting on that body at a particular instant will be shown in the diagram. And the sign conventions are like this along the x-axis. For this, in this direction, upward direction, and this right direction will be having positive signs and other signs will be taken as negative. And if a body will be drawn just like a draw, no shape and size cannot be drawn. It's not necessary, and will be only the forces acting on the body will be shown, and we need to calculate net force from this. What is the purpose of calculating net force? Net force will be, if we calculate net force, we can say how the body is moving and in what direction it is moving. And today's homework is you write in your notes about what is free body diagram. Try to draw a moving car on a road and try to show the free body diagram and show the forces acting on the body. And that's all for today. Thank you.